All right, guys, we have to finish up our slope notes. So we have already done page 52 right here. So we're going to take a look at page 51, which this one I have in there sideways, so that's why it's maybe a little strange. So when I want to find slope, there are a couple of ways we got to think about it. So depending on what I'm looking at, I might find slope in a different way. So the first way that I might want to think about finding slope is if I'm looking at a graph. So if we open that one up, the way I want to think about finding slope off a graph is I want to think about our rise and run. So when we're talking about rise, we're talking about up and down. Up is positive, down is negative. When we're talking about run, we're talking about left and right. Left is negative, right is positive. Let's maybe make some little notes about that. So positive, negative, negative, positive. And the way to count rise over run is I have to find a nice point on my graph. And what I mean by a nice point is like a crosshair point. So the line is going through where two grid lines cross each other. So a really nice looking point here. And I kind of just always start to the left and look through to see, okay, this one is like a crosshair point. But then I need to find another one that I can count too. So I'm going to start at this one, but I need to find another point where I'm going to end. And so I need to look for another crosshair point. And that one looks good to me here. Now I can find others. So another one would be like right there. But no matter where I go, this slope should always be the same. So if I start with the leftmost point, furthest left, I need to go up or down first. So if I'm starting here to get to the next point, I have to go up. And so I'm going to count how many boxes I go up. And this graph is super teeny tiny and my old eyes are struggling. And so if I draw that line in there, I'm going to count. We got 1, 2, 3, 4, 5. So I went up 5. And then I need to go left or right. And to get to this point here, I have to go to the right. So again, I count how many boxes it takes me to get there, which is 1, 2, 3 boxes. And right is positive, so positive 3. So when we write our slope, which we always use M to denote slope. I don't know why they picked M. Like, why wouldn't they use S? So silly. The amount that I rose, or my rise amount, was positive 5. My run amount was positive 3. And if I could reduce, I would reduce, but I can't, so I won't. So that's my slope. And it happens again here too. Like if I count up and over to get to that next point, it'd still be 5 and 3. So it's a good way to check yourself because no matter where you go, it should always be the same. Now you also want to make sure that the sign of the slope makes sense. So remember last time we talked about positive slope always looks like a line going up, starts down, ends up. Negative slope starts up, ends down. We also talked about zero slope and undefined slope, which I didn't have on here, which I should have. And zero slope is always horizontal, and undefined slope is always straight up and down. So vertical. Okay. Another way to find slope is if I'm looking at a table. So if I'm looking at a table, the way that I like to think about slope is change in y over change in x. So if we look at how the y values are growing and how the x values are growing, that will help us get our slope. So from -2 to 4, that's actually up 6. 4 to 8, that's up 4. That's weird. 8 to 10, that's up 2. And then we're up 6. So that's strange. They're not all the same. That's kind of weird. Then we also have to check our x's. So the way that x is growing here from -1 to 2 is up 3. From 2 to 4 is up 2. From 4 to 5 is up 1. and from 5 to 8 is up 3. So the way that we actually do this is if we think about our change in y over change in x, no matter where I go, it should always be the same ratio or the same fraction. So like here, I went up 6 for y, but I went up 3 for x. That actually reduces to 2. And if I think about the next one, it went up 4 and then up 2, which is also 2. So even though they're not constantly going up by the same amount, they kind of are because the ratios are the same. And so then like the next one went up 2 and up 1 in x, which is 2. And so no matter where I go, the ratio is always the same. The change in y on that last one from 10 to 16 was up 6, and from 5 to 8 was up 3, and 6 over 3 again is 2. So it kind of didn't look like it was doing a thing, but when I find the ratio, the change in y over change in x, they were always the same. And so my slope is 2. Okay, probably the most common way to find slope is from ordered pairs, which we use our slope formula, which we just think of as y minus y over x minus x. And again, that makes sense because y minus y is just figuring out the difference in y or the change in y or how much I'm going up or down, okay? And then over x minus x. So the weird thing about this one is y always goes on top or kind of first, which is opposite of our ordered pairs, because in an ordered pair, x is listed first. So if we think about this example on the front, which is right here, my slope formula is y minus y over x minus x, and the ordered pair goes xy, xy. So when I do y minus y, I'll have negative 3 minus negative 6 over 2 minus 5. Now double negatives will make a plus, and so negative 3 plus 6 is 3, and 2 minus 5 is negative 3. And then I want to see if I can reduce, which I can. 3 divided by negative 3 is negative 1. Now the interesting thing is here, you maybe remember the little 1s and 2s from our last notes. And maybe you've seen the slope formula before with little 1s and 2s in it. I don't put them in there because we really don't need them. If I take that same, or those same 2 points, 2 comma negative 3 and 5 comma negative 6, if I swap the order of the y's, I'll still get the same slope. So originally I did negative 3 minus negative 6. If I now instead do negative 6 minus negative 3, well then I also have to switch the x's. So 5 minus 2, I still get a double negative, so a plus. And negative 6 plus 3 is negative 3 over 5 minus 2 is 3. And so I still get negative 1. The only difference was where the negative was, but it doesn't matter because overall, if there's one negative, it's going to be negative. So I just want to point that out. You can subtract in either order. You just have to be consistent. If I do the first y first and the second y second, then I have to do the same thing with the x's. So just be careful there. And then last but not least, if I'm looking at the equation, the number next to x is always your slope. So, boom, slope. But we have to make sure that y is alone before we decide. So, in these few examples here, y is alone, and so the number next to x is my slope, so negative 2. I don't have to do any math. I just look for it. Again, in the next one, y is alone, so the number next to x is half, so my slope is a fourth, excuse me. Third one down, y is alone. There is a number next to x. It's just kind of hiding. It's a 1. There's always a 1 in front of x if I need there to be. The last one, however, y is not alone. So I need to get y alone by getting rid of that x. So I subtract the 4x on both sides, and I would have negative 2y. Now I can't subtract here because they're not like terms, so 6 minus 4x is just going to stay. Excuse me. And y still isn't alone. It's being multiplied by negative 2. So I need to divide everybody by negative 2. And so when I do, I end up with y alone. And then 6 divided by negative 2 is negative 3. And negative 4 divided by negative 2 is positive 2. And that's next to x. So my slope is 2. So if y isn't alone, you might have to do a little work, a little math to get your slope. But if y is alone, slope's easy. It's next to x. All right, there you go. Hopefully that helps.